All right, so today we're finally going to be talking about rationalizing the denominators. And so in the previous couple radicals, we didn't do that. So rationalizing the denominator has to do with what I've got typed right up here at the top. If we are having something in simplest form, we're not allowed to leave any radicals in the denominator of a fraction. So our strategy for getting rid of those radicals in the denominator is to multiply the fraction by a helpful form of 1. And that helpful form of 1 is going to vary depending on what your denominator looks like. If your denominator is just one term, so something like what you see here in A, where there's just one monomial, a single radical in the denominator, then the helpful form of 1 that we use is A over A, where A is the denominator. So whatever the denominator is, we multiply by that over itself, and that's the helpful form of 1 that we use in those cases. If the denominator is more than one term, so a binomial like you see in B, C, and D down here, then we multiply by B over B, where B is the conjugate of the denominator. So we've worked on conjugates several times. So our helpful form of 1 changes depending upon what our denominator looks like. So first thing we're doing here in example 1 is just finding the conjugate. Remember that if the original is A plus B, then that means the conjugate is going to be A minus B. So here's the key. The two terms themselves do not change. If it's a radical, it stays a radical. If it, has an x, it stays with an x. The only thing that changes is the sign that's between. So if the original was a plus, the conjugate is a minus. If the original was a minus, then the conjugate is a plus. So when I look at A, the two terms are square root of x minus 3 and 7. So I keep those exactly the same. The only thing I change is the sign in the middle. So in this case, make it into a minus. So same thing on B. So think in your head of what the conjugate should be. And hopefully you came up with this guy. One thing, do not change the sign underneath the radical. That's part of the term, and the terms themselves do not change. So don't let them trick you, by them like changing this to a plus and changing this to a minus. We don't do that. We only change the sign between the two different terms. All right, so in example 2, we're actually going to be doing the rationalizing because we're trying to find the equivalent expression. So if I multiply here, part A, I have just a one-term denominator. So that means I'm going to multiply by A over A, where A is the denominator. So the denominator is radical 6. So I'm going to multiply by radical 6 over radical 6. Remember that when we multiply fractions, we do top times top, bottom times bottom. So 8 times radical 6 is just 8 radical 6 on the top. On the bottom, remember that one of the rules we went over in the previous video is that any radical times itself is that same number without the radical symbol. So radical 6 times radical 6, which is radical 6 squared, is just plain 6. And then we have to simplify. Don't forget the simplify step. So in this case, I have two plain numbers here that are both divisible by 2. So I'm going to reduce that. Do not reduce the radical part because you only reduce radicals with other radicals, plain numbers with other plain numbers. So this is all I can do here. That becomes my final answer. In B, this is a binomial in the denominator. So there are two terms. which means we're going to have to multiply the top and bottom by the conjugate. So our helpful form of 1 is going to have radical 5 plus 5 on the top and the bottom, because that is the conjugate of the current denominator. So on the top, I'm not going to distribute first. That's kind of a strategy that is usually good to use when we are talking about rationalizing, is we may eventually distribute, but I usually wait to do it. So we're going to multiply radical 15 times this whole thing in the top. On the bottom, we have to do radical 5 minus 5 times radical 5 plus 5. Now, in the denominator, these are binomials, which means to multiply them, I actually have to FOIL. So I'm going to keep the top the same for now. And in the bottom, I have to FOIL. So radical 5 times radical 5 is just a plain 5. The reason we use the conjugates is because if I look at my outside and my inside terms, I have positive 5 radical 5 and negative 5 radical 5. They cancel each other out, so that's why we use the conjugates, because the outside and inside terms of conjugates should always cancel out. So really, when you do your FOIL, you can just do your first and your last. So my last would be negative 5 times positive 5, which is negative 25. All right, so I'm going to go ahead and distribute in the top now. So radical 15 times radical 5, and then radical 15 times a plain 5. Remember, you can't do anything with that because one's a radical and one's not. On the bottom, I now have negative 20. This radical right here can simplify because 15 is 5 times 3, which means I've got a pair of 5s right there. So that gives me 5 radical 3 plus 5 radical 15 over negative 20. Now here, you can either factor out the 5 or see that they should all reduce by 5. So if I factor out the 5, that would give me radical 3 plus radical 15. And then I can reduce. So 5 divided by 5 is 1. Negative 20 divided by 5 is negative 4. And so then for my final answer, running out of space here, but I've got radical 3 plus radical 15 over negative 4. And that would be my final answer. Notice I no longer have radicals in the denominator. So if you have any choices in your multiple choice where there's still a radical in the denominator, it's not the right answer. All right, C, same idea, but this time we have variables within our radical. But because it's 2 terms, that means the helpful form of 1 that we're going to multiply by is the conjugate of the denominator. So instead of 4 plus radical 8x, it's going to be 4 minus radical 8x. And so that's what we multiply by in both cases. So I've got on the top 4 times 4 minus radical 8x. On the bottom, remember what I said about the outside and inside terms, so I really only need to do the first and last. First, 4 times 4, which is 16. Lasts would be minus, because it's a plus times a minus, minus 8x. And so here, there's a lot of things that are going to be able to be factored and simplified here. So first thing I'm going to do is factor out an 8 from the denominator. So 8 times 2 minus x What that allows me to do for right now is to reduce these. So 4 divided by 4 is 1. 8 divided by 4 is 2. Now, the tricky thing here is that my original radical wasn't fully simplified. This 8, if I do a factor tree on it, 8 breaks down into 4 times 2. 4 is 2 times 2. So I have a pair of 2's. So really, that needs simplified to 2 radical 2x over 2 times 2 minus x, which then means, because these are both plain numbers divisible by 2, that I can pull a 2 out of that. Which then cancels these. So that gives me 2 minus radical 2x over 2 minus x. I cannot reduce these 2's. They are not separated by multiplication like these guys were. So they're attached to the other terms. There's nothing else I can do there. All right, very last one here. So again, 2 terms in the denominator there, so that means I need to multiply by the conjugate. So in this case, both of my terms are radicals. That doesn't change my helpful form of 1. It's still going to be the conjugate of the denominator. So radical x was my first term. My original had a minus, so this one should have a plus, and square root of x minus 6. And so those up there. I'll leave the 12 out in front for now so that it's separated by multiplication, so that if there's anything that can reduce with it, I have that opportunity. So that's why I said it's kind of a strategy to not distribute at the beginning, to wait to see if you have to, because you may get things to cancel. So I know the outside and insides are going to cancel, so I'm just going to do the first and the last. So first, radical x times radical x is plain x. And then I have minus, and because this is a binomial under the radical, I need to use a parenthesis. So square root of x minus 6 times square root of x minus 6 is just x minus 6. So simplifying in the denominator itself, so keeping the numerator as is again for now, I distribute my negative, which gives me minus x plus 6. So I have x minus x, so those cancel, and then just a 6. So here's why I don't distribute. You could see it, in the last one where the 4, reduced with the 8. Here, the 12 reduces with the 6. So divided by 6 is 1, divided by 6 is 2. So my final answer then becomes 2 outside of radical x plus radical x minus 6. In most cases, we would leave it like this in factored form, but you could technically distribute the 2 and that also be correct, but we don't really need to. This is good enough as far as our simplifying. All right, so make sure you do your practice and reach out if you have questions.